Thank you for registering for today's webinar, Mastering Interactive Dash Apps with Dash.jl. My name is Sanjeev Das Gupta. I'm the Marketing Manager at JuliaHub. Today's webinar will be presented by Maja Gwóźdź. She's currently pursuing her Masters of Science degree in Theoretical Computer Science at ETH Zurich. After the presentation, we'll open the session for Q&A, and you can post your questions in the Q&A section, and we'll answer them in the order that we received it. Over to you, Maja.
All right. Thank you so much for this introduction, and thank you for everyone for signing up. So today we'll analyze a data set that's basically supposed to serve flight traffic visualization, and even more specifically, we will actually use Dash and Julia, of course. So first of all, you probably have all used Julia to a certain degree, and you might have heard of Dash, also from other frameworks. First of all, we'll basically start with talking about rudimentaries of Dash, and then we'll also tell you what you can achieve with it. And we'll show some templates that you can adapt for your own purposes and projects. And then the most important part of this webinar will be how to launch our custom app on JuliaHub. Our demo will be using data science packages that are very popular in Julia, and we'll also teach you how to combine and recognize Dash elements and how to modify them with HTML. And then we'll discuss certain geographical plots, and we'll discuss certain projections that you can use to plot geographical data. What is Dash? In one sentence, it could be described as a minimal framework for rapidly building data apps. So it's perfect for prototyping and for visualizing time series and for disseminating basic visualizations on the net. It's extremely versatile in a sense that you can adapt very basic components to your own needs, and you can basically show your data, a variety of data. So for instance, those are just several applications that are very popular, but it's not limited to it. So first of all, it's for interactive dashboards, as the name itself suggests. And it's also great for business analytics, for prototyping, and also for educational purposes. And in the context of Dash.jl, so Dash for Julia, it's an extremely nice and universal framework if you want to build interactive components in a very short period of time. So you can actually achieve some really complex and interactive visualizations using a template. So you don't even have to write that much of your own code. You can just take a template and modify it according to your needs. Right, the most important thing probably that you might ask is how do you actually install it locally? We won't be doing this because we'll be using JuliaHub. But if you just want to install it locally right now, you can go to your interactive Julia, so the REPL, and then in package mode you just type add dash, and that's it. So if you're running the latest version, you shouldn't really experience any problems at all with the installation, and it's really fast to get Dash working locally. And then here is something that you might have seen already somewhere. It's a very canonical Dash example. We don't want to go into the details just yet. We just want to focus on the general structure, and we want to identify components that are universal across all Dash apps. So first of all, you need to tell Julia that you're actually using Dash. Then here you need to instantiate it. And in the layout section, you basically specify, well, as the name itself suggests, you specify the layout. So you can also define fields for input, and then finally you can also handle output, which we'll see a bit later. But in this example, you just see if you run it using this line, you should see a minimal example, which will come in just one slide. So you can also specify what the menu looks like, so drop-down options, and then you'll be able to construct even more complex examples, like building on a very minimal example. So as a result, you should be able to see this if you actually run it. So you get an interactive drop-down menu and also multi-select. Then you have radio items, which are those, checkboxes, sliders, and text input. And as you can see, you can already handle this variety of input types. So if we scroll back, you will see that this code is it's just a couple of lines really, and it's all pretty standard. So if you have some previous experience with HTML, at least to a certain intuitive degree, you will see that you will recognize those elements here. And it's extremely easy, for instance, to construct the slider. Like if you just look at this part here, you can achieve this very quickly. So you should already appreciate how easy and intuitive it is. And I hope it will be even more intuitive once we finish this webinar. How do we achieve this interactive behavior that's the defining feature of Dash? Well, you do it with callbacks. We'll later define what callbacks are. We'll give you examples and how to manipulate this behavior. But in very rudimentary terms, callbacks define how you handle the input that you get from the user. So what you actually do with it, how you manipulate this data. So in this case, we have a callback here. And as you can see, it's also quite easy to understand in a sense that you just use the instantiation of your interactive application, and then you just do something with this output. You take this input that you previously have, and then you have this do block. And then actually at this place, you just manipulate this input. So this will actually give you some very basic echo-like behaviors. So basically, whatever the user inputs here should be output at this point. This is already quite, I think, trivial in a sense, but what I want to highlight at this point is how easy it is to get to this behavior and how easy it is to reuse this template if you want to adapt it to your own needs. And it's all great, but you might rightly ask, how do I actually use it with my own data, and how do I adapt this template? And we propose a solution at JuliaHub, which is based on launching Dash projects directly. And we'll see very quickly how to deploy your own Dash app on JuliaHub, and how easy it is to get everything set up automatically for you. So we don't have to worry about specific details and so on. If you wish, you can also, of course, do it locally, but you have to pay attention to a couple of things. So when you're just starting out and using default templates, we recommend that you use JuliaHub because it's much more intuitive. So for the purposes of this webinar, we have to have some data. And I prepared some made up flight traffic data, which we'll inspect in a moment. And we'll also show how you can load it via the CSV package. And then just in one line, you can convert it to a normal Julia data frame. And we'll be able to manipulate this data. So it contains some very basic geographical and positional information like latitude, longitude, and flight IDs, which we then use to plot the flight locations. And at this point, I'll just quickly say that if you're familiar with, for instance, flight radar, where you can track planes flying in almost real time, that's the general idea, but we won't be using this dynamic tracking here. We'll just focus on the static representation. So basically, we'll just treat planes at a specific point on the map, and we'll just see their location, but just statically, not dynamically. So we won't see planes moving in a sense. So it's a bit of a simplification for this webinar. Yeah. Right. So let's see our data set. As I said, there's nothing mysterious about it. It's just a made-up table. So to the best of my knowledge, those planes should exist. So I think they're all actually normal aircraft types, and those origins and destinations are also real-life data. But here we just encode the geographical location, and I auto-generated this data to sort of space them out evenly on the map. And we have some flight IDs, unique flight IDs assigned to each flight. And here it is. So going back to our story, what we want to achieve is to show that Dash components are all really easy to understand and convenient to manipulate if you have templates. So you don't have to start from scratch if you just want to adapt it to your data, because chances are that someone has already written this template, so you can either find, for instance, a time series visualization somewhere in our tutorials, but you can also find them on the web. There are 4 main components to a Dash app. So first of all, you have to initialize it somehow. Then you need to specify the input, and then you need to logically manipulate the input. So that's where callbacks come in. It's basically another way of saying output handling. And you also need to specify where it's supposed to run. So you can just specify the port to your local host, and you actually need to run it somewhere in your code. So what we want to do at this point is take a very high level view of our code for this webinar. We'll discuss all the details a bit later when we have the necessary tools. But at this point, I think you can already identify the components yourself. So for instance, at this point, you need to tell Julia that you're actually using Dash and some auxiliary packages for data handling and plotting. And you also need to specify the path to your dataset and then turn it into a data frame. Here comes instantiation of your app. At this point, we handle the input somehow, and then we have this interactive component at this point. So this whole block is a callback, and here you need to manipulate this input to get the desired interactive output. As the last element, we need to run the app actually. So that's where we achieve it. And here you can see that those components are clearly defined and they are separated. So once you've actually defined your input, you can then move logically to the next step and so on. Right, so what are we actually going to build? I think it makes sense at this point to look at the result so that we see what we're actually building towards. And this is just a snapshot of those things. So we'll have a title, a very basic title without any fancy layout. And then we'll have a drop-down menu, the radio elements, and an interactive map. And here we have 2 projections. So this is the equirectangular, and this is the orthographic projection. And we can also inspect it interactively. If you navigate to projects, once you're on JuliaHub, you can create your own project. At Dash project more specifically at this point. For the purposes of this presentation, I've already done it, but it's really very basic. So you just follow the setup wizard and you basically feed it your own data. And here we have the source file. So we put the dataset and the demo code, and we also have some auxiliary driver code, which I'll show right now. This is something that comes with your default Dash project. So you get this, so to speak, for free on JuliaHub. You already have this template. You basically need to we say that we specify the base path to the directory where you put all your data on JuliaHub, and then you include the actual file with where you specify your Dash app. So you go through the base path to your source folder, and then you just say what file you want to run. And at this point, you just run this app, and that's all. So if you have your very own project and you change this name to, I don't know, to my project 123, then the only thing you have to modify when you're on JuliaHub is basically just this name, just to make sure that it knows what to run. Exactly. So we actually launch it, you have to switch to source, and then there is this button here which says deploy, and you will get a prompt on exactly the setup. So we're on free tier right now, and we have 18 hours for free. So everyone can get 18 hours for free, so you can run your own applications. The important thing is that you have to specify the same port number as you put in your code. So we put 8 null 5 null. And I think this is the only detail that you should pay attention to. You can also specify the time limit and so on. So we just hit start, and you need to go, you can either connect directly here, or you can go back to your home tab, and you should see your jobs at this point. And this is the latest one. So what you do, you just connect to your application. It takes about, I think, 1 to 2 minutes maximum to get this to run. So we can quickly say what we'll do next in the meantime. What I want to do specifically is to inspect the data and to make you understand how you actually load a data frame. This is extremely easy. You just need one line for this. And then ultimately we want to analyze the whole app. So it's about 50 lines, I think, or even less, to understand how you can build it step by step. And finally, I want to show you how you can adjust, for instance, projection options, some plot options as one, to visualize your data in a very clear and intuitive way. First of all, I mentioned that you need to load some simple data science packages, just two, basically, CSV for reading CSV files and data frames for converting your CSV input to a data frame. Right, let's see if it's ready. We just need to wait a bit longer. Not a problem. So this is just a technical way of explaining, I think, a very detailed way of explaining how to read your input and to convert it to a data frame. So basically, in just one line, we read the input. Here is the name of the data set, and then in the same line, we convert it to the data frame. DF is a convention. So if you want to call it anything else, you can. It's not a problem, but I think especially if you're using Dash templates, you will usually see DF. So it's nice to get used to it. There is also another way of achieving the same result that I used here, just to illustrate it. You can also write it like this. So that's the same part. You just specify what file you have at this point. So you just need to include the path to your dataset, and then you turn it directly to the data frame, and that's all. Okay. So now we need to build the Dash app step by step. How do we actually do this? So I'm basically reiterating the things I said before, just to show how modular it is in a sense. So you can build a Dash project on JuliaHub basically in seconds, because if you launch a blank project, you will get a template that's ready with a visualization. So we have a graph, and you can basically feed it your own data and get a different visualization. If you want to achieve something more complex, like we'll do here, you just need to navigate to a different template, or you just need to read the documentation, which is also very user friendly. But for the vast majority of cases, you won't need anything apart from this. So the first thing you need to do is to turn it into your data into a data frame. And the most important part is really understanding how callbacks work, so you can achieve the level of interaction that you want in your app. So you can very precisely manipulate the input. In this webinar specifically, we'll also focus on using various maps for a specific purpose, which is flight traffic visualization. But you can really guess that it can be adapted to any sort of if you have positional data, geographical locations, you can adapt it to any use case essentially. First, you need to load Julia packages, and then you need to create this Dash app instance to start the whole process. So it's essentially one line, and obviously you can call it something else, but again, I think it's a nice convention to just call it app, because it will show up in a lot of places. So this is basically the first line you have to do. And this is again the driver code that I mentioned. Again, this is something that you get with the default template on JuliaHub, so you don't have to worry about this. But you just have to pay attention to specifying the name, the name of your file, basically, and that's it. And obviously, you have to also to specify it here, but it's just a simple matter of replacing lines. And then you have those very high-level HTML elements. So if you specify your layout, you might want to use those elements, and we'll see exactly what they do and how to achieve very precise behavior of the input. But if you know a bit of HTML, you already know the whole mystery behind this. So yeah, it's also very nice that you can combine this sort of knowledge. Just quickly see. Okay, great. So let's just jump to this live demo right now before we actually analyze the details of this code. So first of all, this is just exactly our Dash application. And here is the drop-down menu. So if you're interested in the position of a specific aircraft model, you can just, for instance, click on Airbus 320, and then you get only those. So you filter the results, and you can inspect them. As you've probably noticed, when I hover over a data point, I get its positional data, and also I get a flight number, so the flight ID, basically. And if I want to switch to the 3D view, I can also click on orthographic projection, And the nice thing about this is that you can use it interactively. So you can basically use it like, I don't know, like Google Earth or for something. So you can see all the flights where they are at this particular moment. And then you can also take screenshots, you can zoom in, zoom out, and so on. You can also reset your view. So this is what we're building in this webinar. And it's good to keep in mind that this is the end result that we want to achieve. So now that we actually know what we want to achieve, we can discuss callbacks in Dash. Formally speaking, a callback connects the input from user in interface components. So for instance, drop-down sliders or those radio elements to output components. In this case, those would be charts or graphs. And they define how the data updates in response to user interactions. So on a very intuitive level, when you move the slider, you actually expect, as the end user, you expect something to change on the graph. Again, the input, those are just user actions or changes in the user interface that trigger the callback specifically, and the output are those updates or modifications in response to the callback. And the function is actually where the magic happens, really, because it's a function associated with this callback. So it contains all the logic to manipulate the updates. So it basically it specifies how the updates should be performed based on the specific inputs. Moving to code examples, this is a very this is just an overview, an abstract overview of callback code. So you have a callback function, and then your instance of the app, which we just call app to illustrate it better. Then you have your output, desired output, and then specific input. And then you have the do block, which does the update, which contains the whole logic behind the update. So on a very high level, it's just do something and then return something, and that's it. But we will see in a second what this something stands for. In our case, the callback, the signature of the callback will be, again, the instance of the app. So you need to take the ID first and then the property. So in this case, our ID is flight map. That's just one output that we have, and there's a property, and then again we have two inputs actually. So it's a kind of a combined callback because we actually want to react to two different things. If we quickly move back to our interactive example, you can see that one input element is actually the drop-down menu. So we need to somehow react to this action, and then we also need to react to this one. So it's actually about choosing projections, right? So you have the aircraft model, but you want to see it in 3D, so to speak, and then you need to switch. You want to switch back, right? So we clearly see that those are two outputs. So in a sense, it will get a bit more complicated. So the more things you want to react to, the more complex the callback function needs to be, logically speaking. We'll use a geographical scatter plot, as you already saw in the live demo. Basically, we need to somehow encode, the position. So the easiest way to do it is to use y and x coordinates, and the mode of the plot is how you want to represent your specific data point. So in this case, it's called markers. So basically, we statically represent each flight as a distinct marker, so distinct dot on this map. And then text, you can already guess, it just provides some additional information that you might want to to put next to the flight. So in this case, it's when you hover over, that's the additional information essentially. Again, the marker then will have a specific dictionary for adjusting the visual appearance. So for instance, you can control size, you can control color, and so on. And finally, we also have a projection type. So we have orthographic projection or equirectangular, and we encode it by means of the selected projection variable. And that basically accounts for the dynamic switching of the projection and also improves interactivity. Again, we can configure map appearance, for instance, the scope. World in this case, we're interested in the global view, but you can also restrict it to specific locations if you wish. We also want to display landmass. So in this case, those would be, for instance, oceans. We want to display them to make it more realistic in a sense. As you probably guessed, we can also manipulate land color and country color. So land color would be, for instance, setting oceans to blue, or country color defines the boundary colors of countries. And then we also want to show those borders, because it makes it more more realistic, again, more useful in a sense. But you can play with those values and then see what happens if you set it to different values. So what actually happens inside this callback? So what's with the do block? Here is our example. First of all, we want to react differently to the input, whether it's all. So if the user chooses all aircraft types, we'll get different behavior, different output. But if they actually choose just one aircraft type, a specific unique type, we need to filter our dataset to account just this specific information associated with this aircraft type. Maybe it's obvious, but I think if you're building your own application, which is not just confined to this flight data, you will run into a similar problem in a sense. You need to define this behavior for all data points, but you also need to define separate sort of behavior for specific subsets of your data, essentially. For the layout, we have a DCC elements. This stands for Dash Core Components. They basically define or describe the layout you want to achieve, and then the interactive, how you achieve interactive behavior. So for instance, you can define the layout by resorting to Dash HTML. You can define for instance, radio items like we have done, drop-down menus, and so on. So those are basically UI components that you need to encode this whole logic, interaction logic. So for instance, a drop-down has a different kind of logic than radio items and so on. And exactly, then you just use an HTML, so parts of HTML to organize this layout. In our case, we have radio items. So those are those circles here that you can click on, and they define the output. We also have the graph, obviously. This is the central part of the app, and the drop-down menu where you can select aircraft types. And now let's just dive into the code. So we've discussed enough details to be able to analyze this code and actually understand what happens. I don't really expect it. So I don't expect you to follow everything from a syntactic point of view. What I want to achieve here is, because we have obviously limited time and so on, but the whole purpose of this analysis line by line is to achieve how you can understand and actually adapt it later on. So if you have this template, you will know what's going on. So you will be able to delete or add certain elements to suit your particular project. And this is what the main takeaway from this webinar. First of all, we just define a title, then we define additional text, which is a bit smaller. This is not interesting. What's interesting is this part. So we have this drop-down layout, the drop-down menu, where we need to define certain options, obviously. So the label, so this part will actually show text to the user. So you can call it anything. I mean, it's best to give it meaningful names, obviously, but what I want to say is that the label is different from the value. So at this point, we could just call it my favorite dropdown, and instead of all, in this place, we would get my favorite dropdown. So what you're modifying at this point is the name itself, but not the value. The value has to make sense from the syntactic point of view, so to speak. And then we want to define specific labels for aircraft type, and the value will come from your dataset. So whatever you write in your dataset, it will be reflected here. And obviously we want to choose unique aircraft types. So imagine that we had duplicates for Airbus A320. That wouldn't make any sense because you wouldn't be able to filter through the results in a meaningful way. So the obvious choice is to filter your dataset and to choose unique names to be able to display your data in a logical way. Then you also need to specify default behavior, so that the default value will be all, which makes sense. And as for the radio items, it's just about choosing the projection. So here we display the text. We display the text equi-rectangular, but it's meaningless in a sense that you could put anything here and it would still work, but the value has to be syntactically correct. So it has to agree with the framework within which you're working. So this is the value from the syntactic point of view. And again, we set the default value, which you know from the previous example. And then we also specify that we want to have a graph, and we just give it some custom ID. It's always best to call things in a meaningful way. And then we also have the text flight details when you hover over the flight. Now to the most important part. So how do we actually achieve this sort of interactive element? Because at this point we've just defined the layout. So we just we defined what values are possible to choose from, and we defined the labels and so on. This is the most important and interesting part. So we built the callback gradually. First of all, we need to fill in the details. So we have our instantiation of the app, and then our output, we just have one output. So that's the figure, the flight map. So basically anything that's here, we just have one output, right? But we do have two inputs, which is again clear because the user can either, for instance, choose something from the dropdown, but they can additionally choose the projection type. So we need to react to two inputs at the same time. And here we have do block. So we need to react to the aircraft type and also to the selected projection. First, we want to react to the drop-down menu. So if it's all, if they choose the option all, we just display the whole data set. So we return this. But if they actually choose a specific aircraft type, we want to filter our original data set to account just for those values that are relevant. And then we need to react in an intuitive way to the projection. So if they chose a specific projection, we need to encode it somehow using variables, of course. So we want to define the map layout, rather the map type. The layout comes a bit later. So we use the scatter geographical plot, like we discussed before, and we need to pass latitude data here using this variable and longitude data at this point. And then, like we said, we use markers, so just points, specific points on the map, and then we just filter, use text, we just filter them by flight ID to display additional information. And at this point, we can set the desired size and color of our points. So again, this is not arbitrary in the sense this is not just some usual text. If you want to change this, you need to check the documentation. You need to check the list of colors that are allowed, basically. So yeah, so we just need to see a predefined list of colors. As for the layout, we can call it, well, we can give it a meaningful name, and then we need to somehow encode or specify the behavior of the geographical data, so the map itself. We can specify scope, also choose the right land color, country color, so on and so forth. And at this point, I think this is the most important part, we need to react to a different projection. So normally you'd have something like type and then equirectangular or just orthographic, for instance. But in our situation, we need to account for the fact that we have two options. So we need to pass the variable that will change based on the user input. And then finally, we want to plot it somehow. So we need this return statement here. And first, we need to take our the basic map data, and then we need to superimpose kind of the layout in it. So it's a kind of additional and complementary information. And in the very last line, we need to run the app. So you just type run server, your instance of the app, and then you specify localhost and the port. And that's basically it. That's the whole mystery behind this app. Yeah, so that's all from me. I hope you find it well, useful in your own projects, even though it's specifically confined to geographical information. But you don't have to worry about this example. You basically, I mean, you don't have to worry about us using maps in this case. You could just as well, for instance, delete all of this and redefine the type of the graph, and you'd get completely different use case. So it's extremely universal, even though we're using projections and land masses and stuff like this. So thank you very much for your attention. I will now be happy to answer any questions that you might have. Thank you.
Thank you, Maya. You can type in your questions in the Q&A section, and we'll pick it from there. Maya, there's this question, how to customize scatter geo even further, and how easy is it?
Oh, I see. That's a very good question. So it's actually, so the answer is it's very easy, as it should be. For instance, you can, if you don't want to restrict the scope no, in this case, we don't restrict the scope. If you want to restrict the scope, you can just as well type, for instance, USA, and you would get a predefined map of the USA. You can also add, for instance, heat maps to it to see behavior in different states, to react to data from different states. But there are lots of options, so best advice would be just to go directly to this documentation website. But yeah, you can even specify continents and so on.
Thank you, Maya. And there's another question which says, we focused on a static application. Is it possible to do a simulation with respect to time?
Yes. So I anticipated this question in a sense, because flights are usually associated with dynamic data. So if you want to if you want to use sliders, for instance, that would be the simplest example to account for some sort of dynamic change or a continuous change in a sense, then you can use it as well, and it's also easy to set up. For instance, you could combine it with heat maps, and sliders work very well with heat maps as well. So there's also a separate documentation page with tutorials on how to set up sliders and account for dynamic data. Yeah.
Thank you, Maya. Any other questions? You can please type it in the Q&A section and we'll answer it in the order it comes in. Let's wait for a couple of moments, Maya, in case there are any questions.
Sure. Okay, so the next question is it possible to have asynchronous callbacks in case the processing is too long? That's a very good question. And so I'm not aware of any special mechanism, like a locking mechanism that exists for Dash.jl in case of asynchronous callbacks. You could very easily achieve the same behavior. So in case this option exists, then the answer is trivially yes. In case it doesn't work, you could, of course, for instance, you say too long. So I expect you could just put some very basic time measuring function in between. And if you don't want to wait, for instance, longer than 10 seconds, you could just say, you could use a if then else block, and you could easily switch to another option, like another option based on the timing function. Yeah.
Thank you, Maya. Let's see if there are any questions coming in. Else we can probably call it a day in another couple of minutes. Okay, I see no more questions coming in. So maybe we can end the webinar here today. Thank you everyone for joining the webinar. In case you have any questions, you can reach out to sales@juliahub.com, or if you want to attend our future webinars, Maya has shared the link. You can go to our website and have a look at the future webinars and register for them. The video of this webinar will be shared with you over an email so that you can view it at your convenience. Thank you a lot. Thanks a lot, Maya, for this insight.
Thank you so much.
And we hope to see everyone once again in our future webinars. Have a great day.
Thank you. Bye.
See you. Bye.